All right, Chapter 1, Section 2, Measuring and Constructing Segments. At the end of this lesson, you should be able to find the length of a line segment given the coordinates of the endpoints. You should be able to correctly use the term congruent and to use tick marks to identify congruent segments. You should be able to recite and use the segment addition postulate to find segment lengths. And you should be able to use midpoints and segment bisectors to find segment lengths. So how are line segments and lines different? Well, remember that a line segment is only part of a line. Lines go on forever and ever and ever in both directions, where a line segment has two endpoints, has a beginning and an end. So it's only like part of this line. If I would take this chunk right here, this would be our line segment. So today we're going to figure out the distance between those 2 points. We're going to figure out how long a line segment is. So the distance between any 2 points is the absolute value of the difference of the coordinates. The reason we take an absolute value is because absolute value measures distance. Absolute value of a number is how far it is away from 0. So if we find the difference, which remember means subtraction, of 2 points and it's negative, we really don't care that it's negative. We just want to know how far the distance is. So if the coordinates of points A and B are A and B, then the distance between them is A minus B, or B minus A, as long as we take the absolute value. The distance between them is also called the length. Now, I know that's really confusing, but let's do a problem, and it'll make a lot more sense. So, pretend you have this number line here. We could fill in all the numbers if we wanted to. And I told you to find the length. So the length of BC means that we're going to take these coordinates right here, 1 and 3, and we're going to subtract them. And all that was saying on the other slide is that it doesn't matter what order you put them in. As long as we take the absolute value, I could do 1 minus 3, or I could take 3 minus 1, because all we're trying to figure out is the distance between them. So 1 minus 3 would give me negative 2. This would give me positive 2. But because we're taking the absolute value, remember that they both give us a distance of 2. So the length of BC, if I was to draw a segment right here that went from here to here, it would be 2 units long. Now AC is a little different because we have a negative number here, but it's going to work exactly the same. All I want to know is the distance between these. Now I know you're thinking, why don't we just count? And that's totally possible, but sometimes we might not be able to. So if we were to count, it'd be 1, 2, 3, 4, 5, a distance of 5. And we can prove that mathematically by taking the absolute value of point A, which is negative 2, and subtracting 3. We end up with the absolute value of negative 5, which we know is 5. And this would work the other way around. If you started with 3 and you subtracted a negative 2, be careful there. 3 minus a negative 2 really means that we're adding, and we would still end up with 5. So can you find the length of a line segment given the coordinates and the endpoints? Here's our segment addition postulate. This was in one of the I can statements as well. Postulate 122 says that if B is between A and C, this should say A, then AB, so this part here, plus BC, this part here, equals AC, which makes sense when you think about it. If you add those two together, you're going to get the total thing. Now, we use that to do some math behind it, and this is where algebra skills come in. We're going to take a geometry concept and use algebra to solve for x. So it says that M is between N and O. Find NO. I got to find this total length here. And it tells me the total length, but it gives it in terms of x. So we need to solve for x so we can figure that out. Now, using this postulate, it says that if I add these two things up, if I add this and this, they should total this whole thing. So that's an equation waiting to happen. I can say 17, which is nm, plus 3x plus 5, or minus 5, which is mo, has to equal this whole thing, which is 5x plus 2. And then we can solve this. We got a ton going on, so let's simplify the left side. There's numbers on both sides, so if I do 17 minus 5, I'll end up with 12 plus 3x equals 5x plus 2. And now I have x's on both sides. We got to pick a side to put them on. I'm going to move everybody to the right. So if I have positive 3x's, I need to subtract them. This crosses off, so all I'm left with on the left side is a 12. And that equals a 2x plus 2. So now that all my x's are on one side, I'm going to move my numbers to the other. So I get 10 equals 2x. Hopefully your head's already told you that x has to be 5. Now usually we box that up, we're done, we move on to the next problem. But remember what it asked us to find. It wanted us to find NO, the distance between point N and point O. So in order to do that, we have to take our x and plug it back in here. So we have 5 times our x that we just found, which happens to be 5 also, plus 2. 25 plus 2, or 27. And that's how long that whole line segment is. And you can check this. If I know this whole thing is 27 and this is 17, this means this should be 10. And if you plug in x, 3 times 5 is 15 minus 5, we do end up with 10. So I can recite and use the segment addition postulate to find segment lengths. So now some words. First thing that we need to know is the word congruent. And congruent has a symbol, looks like an equal sign with a squiggle over it. And we use congruent when we talk about equal lengths. So congruent is almost like an equals, but we tend to reserve equals for when we're talking about expressions being set equal to each other. So if I have two lengths that are the same, like this guy and this guy, I would say that they are congruent instead of equal. And that's exactly what congruent segments are. Segments that have the same length. And then a midpoint is exactly what it sounds like. It's a point in the middle of a segment. So if I drew something out and told you that the length of this segment was 4 centimeters, the midpoint would be exactly in the middle of that, right here at 2 centimeters. And then finally, the last one is a segment bisector. Segment bisector is a line, a ray, or a segment that intersects a segment and cuts it in half. So if I was to draw a line through, right here through the midpoint, that is a segment bisector. So it's a line, ray, or segment that goes through the midpoint. See how we're taking all those words we learned yesterday and turning them into more math? That's all geometry is. Correctly use the term congruent and use tick marks to identify congruent segments. So one thing we do to say that two segments are congruent is we use little tick marks. Like those two are exactly the same. And if I had other ones over here and I wanted to say that these two are the same, I might use 2 tick marks. So now I know that the guys with 2 tick marks are congruent and the guys with 1 tick mark are congruent. So using a midpoint, if D is the midpoint of EF, and ED equals 4x plus 6, and DF equals 7x minus 9, we need to find ED, DF, and EF. Easiest thing to do when you're given a problem like this is to start drawing this out. If D is the midpoint of EF, that means I have a segment with one end E and one end F. And then D is right in the middle. And then what else does it tell me? It says that I have ED from here to here is 4x plus 6. And then DF is 7x minus 9. Now the last one we did told us the total length of this. We don't need that anymore because if we know D is the midpoint, that means that each of these have to be exactly the same length. So all we have to do for this one is set these two expressions equal to each other and solve. So if I have 4x plus 6 equals 7x minus 9, I'm going to get all my x's on one side, just like I did before. I'm going to move them to this side so they stay positive. Then I got to move my numbers. Oops, this is minus. So I want to add 9 to both sides. 16 plus 9, or 6 plus 9 will give you 15. And then if I divide both sides by 3, we end up with x is 5. Now remember, this isn't our answer. We have to find ED, DF, and EF. So let's do ED first. I know ED is this 4x plus 6. So we're going to plug in what x is. 4 times 5 plus 6. This gives me 20 plus 6, or 26. So ED is 26 units long. And then you could go through and plug this in, but because D is at the midpoint, DF should also be 26. And if you quickly do the math, 35 minus 9 will give you 26. So this is what DF equals. And then we need to find out how long this whole thing is from E to F. So we just add those two parts up. 26 plus 26 will give us 52. So these three pieces here are the answers. I can use midpoints and segment bisectors to find segment lengths. So make sure you can go through and do all these. You can find the length of a line segment if I give you the coordinates of the endpoints. You can use the word congruent and tick marks to identify segments. You know the segment addition postulate and can find segment lengths. And then finally, you can use midpoints and segment bisectors to find segment lengths. Have a good night.